In a previous class, we went over where can you find some additional exercises. And we said if you went to your Blackboard page, and if you went to course content right here, clicked on that, this is where the videos are, but also down here, this is where we said we had some additional exercises where I've made videos going over the whole thing, but I thought what I'd do is go over down at the bottom here some additional work on fractions. So that's what we're going to do. Now in the video above, I go over all of this, but what we want to do here is just review a couple of them so that you have an idea of the strategy of how to do things. So for instance, in this first example, they want you to find the prime factorization. So let's do 27. We'll do it right over here. 27. And we said to make something like this. Now this is not even, so you can't take a 2 out. But what was the rule of threes? If you add up these digits, 2 plus 7 is 9. So you know you can take a 3 out of there. So 3 goes into 27 9 times. And of course, the 9, you can take a 3 out. That would be 3 times 3. And what you have out here now, along the edge and at the bottom, if these are prime numbers, this is your prime factorization. So you would write this 3 times 3 times 3. And if we did this one here as well, we're not going to do them all, just to give you an idea. So this would be 375. Again, it's not even. We could take out a 5, but we want to take out the lowest prime factor first. So let's use the rule of threes on this. 3 and 7 are 10. Add 5 is 15. Is 15 divisible by 3? And the answer is yes. So we can divide this by a 3, which is the lowest prime factor. So 3 goes into 3 once, 3 goes into 7 twice, with a 1 left over. 3 goes into 15 5 times. Now if we add these digits up, we get an 8, so you can't take a 3 out. So this does have a 5, so we know we can take a 5 out of there. 5 goes into 12 twice, with a 2 left over. 5 goes into 25 5 times. And we know this is going to be 5 times 5. So for letter D, our prime factorization along the edge here is 3 times 5 times 5 times 5. Now when I looked at students' work the other day, I saw that in some cases some have written an extra one, or they didn't write enough 5s. So it wouldn't be bad to check your work. So this is 15 times 25. 15 times 25 is 375. And for items like this, we want to have a denominator of 48. So we set it up like this. And our denominator, our new denominator, will be 48. So what do you multiply 2/3 by to get a denominator of 48. Now it has to be some form of 1. And that happens to be 16 over 16. 16 over 16 is a 1. And now 3 times 16 is 48. And 2 times 16 is 32. So there's our new fraction from 2/3 with a denominator of whatever they ask for, in this case 48. Now remember, in the other lesson, the other video, I go over all of these. Here we're just doing a quick review. So here we're asked to multiply, and as you look at it, would anything cancel out here? Cross-canceling or anything? No. So you just multiply your numerators, get 16, and multiply your denominators and get 27. Now if you couldn't cancel anything out here, then this is going to be simplified already. But for this one, when we do 2/3 times this, we can do some cross-canceling. Here we know 3 will go into 3 once, and 3 will go into 21 7 times. 2 will go into there once, 2 will go into there 33 times. So now we can't cancel anymore. It's the numerators, which is a 7, and our denominators 33. And again, if you've canceled out here, once you get to this part, there's no more simplification. Now for this one, these are mixed number fractions that we need to convert to improper fractions. And the rule was you take the denominator times the whole number, that's 7, plus 3 is going to be 10 over 7. And this is 5 times 2 is 10, plus 4 is 14, over 5. Now again, if you can cross-cancel here, that's what you want to do. 7 will go into there once, 7 goes into there twice, 5 goes into there once, 5 goes into 10 twice. So 1 times 1 is 1, which we don't write. 2 times 2 is 4. And you've shown the work of how you did this. Now if this were a division, what we would have done is flip this, and that's how that would have been done. Now here is a division we're skipping. You would again just flip that after you convert it to an improper fraction. For this one, since the denominators are the same, you just add your numerators, and this will give you 20 over 15. But you need to simplify that. You can take a 5 out of each one. 5 out of there is 3, 5 out of there is 4. So this becomes 4/3. And you can usually leave it in this form as long as it's simplified. But I've written this one out. Again, the technique is you write your fractions, put a big line because you're going to put all of this over a common denominator. Between a 5 and a 20, what's your common denominator? Well, it happens to be 20. Now this one's already 20, so we can put the 3 there already. There's this fraction. But now we have to multiply this fraction by a 1 in the form of what that will make our denominator a 20. And the answer is 4 over 4. So 4 times 5 is 20. 4 times 4 is 16. So now we add our numerator, because it's over a common denominator, 19/20. These others are done in a similar way. This one, again, I would separate, add your fractions first, convert it to a mixed number, and then add that whole number, which there will be one, to the 16 and the 12. Okay, well, let's see. We'll do this one as a little review. So, we're subtracting this from this. So, a method to do it is, there's nothing here, so we're going to borrow one from this 100. Make this 99, and then borrow one to the fraction column. And since our denominator is 5, we'll show the one that we're going to have here as 5 over 5. Now we have common denominators. We can take the 3 from the 5 and get a 2/5. And now we take the 12 from the 99 and get 70 or 87. So 2 from the 9 is a 7, and 1 from the 9 is an 8. So there's our answer. That would be a strategy for doing it. Again, there are other ways. If you're getting the right answer, use them. All right, we'll keep this a little short. Hopefully it's helpful.